These notes are on the discriminant of a quadratic equation. The discriminant. So the discriminant, first of all, is a piece of the quadratic equation, and it will tell us the nature of our roots, whether they're two real roots, two imaginary roots, or just a single double root. That sounds weird. Just a double root is what I should say. So first, let me define the discriminant by reminding you what the quadratic formula was, and that was x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We use the quadratic formula, remember, to solve quadratic equations without factoring. And the discriminant is just this inside piece to the square root. So this is the discriminant. Discriminant. So it would be b squared minus 4ac. We call this the discriminant, and it will tell us whether we have the different kinds of roots. So if you recall from the problems that we were doing when we solved quadratics using the quadratic formula, we had three different cases. So when it says when using the quadratic formula, we had three cases. We had three cases, and those cases were, so case one was when we ended up with two answers that were real, two real roots, two real different roots. Case two, I make this distinction because case two will have two roots, but it's a double root, so it's the same. So I'll just say one double root. And when we were factoring, we found double roots all the time, and that's case two. Case three is two imaginary roots, and that's just two roots involving I. So the discriminant is something that'll help us to decide whether it's case one, and we'll have two real different roots, or case two, one double root, or case three, two imaginary roots. If we find the discriminant, then we'll be able to say, oh, case one, case two, or case three. That's the point of this section. So when does the discriminant tell us this? When does it tell us this? When does it tell us this? Oh, we have a neat little box right here that you were given. You could just paste that right into your notes. Can you read that? Yeah. So the discriminant, which is b squared minus 4ac, if the discriminant is greater than 0, then we have two unequal real roots. That's case one. Two real roots that are different. If the discriminant is equal to 0, we'll have one double root, and it will be real. And if the discriminant is less than 0, excuse me, I burped. If the discriminant is less than 0, then we have two imaginary roots. So, we can see this. If the discriminant is greater than 0, then the square root of this will be a real number. So we'll get two solutions with our plus and minus, and they'll be real solutions. If this is 0, then we're plus and minusing 0, so we'll get one solution. That's where the one solution comes from. And if this is negative, we'll have a negative under the square root, which will give us our two imaginary solutions. So that's that. And we can start doing an example. Right away, easy. I'm going to put this in green, actually, because this is something you need to know. The discriminant is b squared minus 4ac. So our first example. The directions will be without solving the equation. Determine the nature of its roots. Determine the nature of its roots. Meaning, are we going to have two real roots, one double root, or two imaginary roots? That's what the question is asking. So we'll start out x squared minus 8x plus 5 equals 0, and we're trying to determine the nature of these roots. All we have to do is find the discriminant and follow the rules in this little gray box. So first we can do that by finding a, b, and c, because we need a, b, and c for our discriminant up here. So first a is just 1, right? Because this is in standard form. B is -8, and C is, what can I use, pink, +5. So there's C, B, A. We'll have 1 for A, -8 for B, and +5 for C. So our discriminant, which is b squared minus 4ac, is b squared, 64, -8 times -8, minus 4 times a is 1, and c is 5. So that equals 64 minus 4 times 1 is 4, times 5 is 20, minus 20. And that gives us 40? No. 44. 654. Yes, 44. So this is positive, right? Which means it's greater than 0. So it's case 1. Then there are two different real roots, two unequal real roots. So our answer here is determine the nature of the roots. We'll have two different real roots. And that's our answer. That's all the question was asking. So that's all we need to do to answer it. Simple. Alright? Another example. Just as easy. Same directions without solving the equation. Determine the nature of the roots. X squared plus 10x plus 25 equals 0. First, find a, b, and c. A, b, and c. So let's actually write these steps down. So step 1, get into standard form. It was already in standard form for us, but it might not always be. So get into standard form. Step 2, after we get into standard form, find a, b, and c. Find a, b, and c. Step 3, find the discriminant, and then you're done. So step 3, find the discriminant. So, if we're following step 1, get into standard form. We already did that. Or, we didn't do it, but it was already in standard form. Step 2 is find a, b, and c. A is 1, B is positive 10. C is positive 25. So now, step 3, find the discriminant. B squared minus 4AC. That will be 10 squared, which is 100, minus 4 times 1, because that's A, times C, which is 25. And that'll give us 100 minus 100. That'll be 0. So we go back up to our gray box. If the discriminant is equal to 0, then there is a real double root. So, since this is 0, our answer will be 1 real double root. And it's just that easy. The discriminant tells us which type of root we'll have, and that's all the question is asking us to do. So that's all we have to do. That's all we had to do.